When space met time, the birth of a new reality. A broken intuition. We experience space and time as separate. Space is where things exist. Time is when things happen. For centuries, this distinction felt absolute. Then physics revealed something deeply unsettling. Space and time are not independent. They are woven together. And that realization reshaped our understanding of reality itself. Part 1. The classical worldview. Before the 20th century, space and time were treated as universal constants. Space was fixed, infinite, and identical everywhere. Time flowed evenly, the same for all observers. This framework allowed physics to flourish. Motion could be predicted. Orbits could be calculated. The universe appeared orderly and absolute. Space was the stage. Time was the clock. They never interfered with one another. Part 2. A crisis in consistency. As measurements became more precise, inconsistencies appeared. Light behaved strangely. The speed remained constant, regardless of motion. This violated classical assumptions. If space and time were absolute, light should behave differently. The equations of physics began to contradict intuition. Something fundamental was wrong, not with experiments but with assumptions. Part 3. A radical reinterpretation. The solution required abandoning a centuries-old belief. Space and time were not separate entities. They were aspects of a single structure. Events could not be described by where alone or when alone, but by both together. This merged framework became known as spacetime. Reality gained a fourth dimension. Part 4. Relativity and the end of absolute time. In this new framework, time was no longer universal. Different observers experienced time differently depending on motion and gravity. Clocks did not tick at the same rate everywhere. Lengths were not the same for all observers. There was no single, privileged viewpoint. Space and time adjusted together to preserve the laws of physics. Reality became relative but consistent. Part 5. Spacetime as a geometry. Spacetime was not just a concept, it had structure. Mass and energy distorted spacetime itself. Gravity was no longer a force acting across distance. It became the curvature of spacetime. Objects moved the way they did because spacetime told them how. Matter shaped spacetime. Spacetime guided matter. This mutual relationship redefined gravity entirely. Part 6. Evidence in the real world. The merging of space and time was not philosophical speculation. It produced testable predictions. Time slows near massive objects. Light bends as it passes stars. Signals from satellites require relativistic corrections. Without accounting for spacetime effects, modern technology would fail. The theory works because spacetime is real. Part 7. Changing how we think about reality. Spacetime altered more than physics. It changed how humans conceptualize existence. The present moment is not universal. The past and future depend on motion. Simultaneity is relative. Reality is not sliced into absolute moments. It is a connected fabric of events. Part 8. What we still don't understand. Despite its success, spacetime raises unresolved questions. What is spacetime made of? Is it fundamental or emergent? How does it behave at the smallest scales? Quantum physics and spacetime remain difficult to reconcile. We understand how spacetime behaves. We do not yet know why it exists. A new way to see the universe. The idea that space and time are connected did not simplify reality. It revealed its depth. We do not live in space and time. We live within spacetime, a universe where motion shapes time and matter shapes geometry. If this documentary reshaped how you think about reality, consider liking the video and subscribing to Interesting MindHub for future explorations. Because the most profound discoveries do not add answers. They change the questions themselves.